All right, last time we talked about an introduction to charge and what charge is. And today we are going to talk about something called Coulombs Law, and that is how charges interact with one another. A little bit of review. The charge on a single electron is equal to 1.602 times 10 to the minus 19 C. And remember, C stands for coulombs. That is our unit for charge. So if we have a single electron, it has this much charge on it. An electric charge is quantized in the units of the electron charge. So remember, we can't have half an electron or third of an electron or 7.2 electrons. We can only have whole numbers of them. So that means we can only have whole numbers times this amount of charge. So I want to know, what is the number of excess electrons on an object if it has a charge of -8 microcoulombs? So the first thing that we need to do is define micro. Micro is a prefix, which means times 10 to the minus 6. So this charge is 8 times 10 to the minus 6 coulombs. And I want to know, how many electrons do I need to make that charge? So I'm going to set it up as a proportionality. It takes X electrons to make a charge of 8 times 10 to the minus 6 coulombs. In order to figure out X, we need another side to our equation. And that is this definition up here. We know that if we have one electron, it will have a charge of 1.602 times 10 to the minus 19 coulombs. So now we have an equation with one unknown, and we can solve. The first step to solving here is to do this out on your calculator. 1 divided by, and don't forget your parentheses, 1.602 times 10 to the minus 19th. And it turns out when you plug that into your calculator, this whole thing goes to 6.242 times 10 to the 18th. And that is still equal to X electrons over 8 times 10 to the minus 6 coulombs. So now we can try and solve for X. And in order to get X by itself, we have to multiply both sides by 8 times 10 to the minus 6. In order to have it cancel on this side. So after we do that, we find that X electrons are equal to 6.242 times 10 to the 18th times 8 times 10 to the minus 6. And when you put that into your calculator, it turns out your number is 5 times 10 to the 13. And what were we trying to find? We were trying to find the number of excess electrons. So if we have an object with a charge of 8 microcoulombs, it has 5 times 10 to the 13 extra electrons on it. So that was a little review. If we have an object with this many electrons on it, how does it interact with the world? That's what we're going to talk about today. So it turns out that experiments show that the electric force between two charges is proportional to the product of the charges and inversely proportional to the distance between them. So you already know from the labs at the beginning of the week and from the last video that like charges repel and opposite charges attract. And they do that in a very predictable way. It turns out the more charge you have, the more force you have, and the farther away those charges are, the less force you have between them. And this brings us to Coulombs Law. This is a really important equation. We are going to use it a lot. You need to become familiar with it. It's going to be difficult to use. I can tell you that because it has a lot of numbers in it, and these numbers are very complicated. So if you have a hard time figuring out how to plug this into your calculator, you need to come see me as soon as possible to get that figured out. Otherwise, you're just going to be in big trouble. So Coulombs Law tells us that the electric force between two charges is equal to a constant which I'll get to in a second, times the charges, and this is the magnitude of the charges, how big they are, and divided by the distance between those objects, or those charges, squared. So electric force is equal to the constant times the two charges divided by the distance between them squared. F equals K Q1 Q2 over R squared. This equation will give us the magnitude of the force, or the number of the force, but it does not tell us the direction. It does not tell us if this force is an attractive one or a repulsive one. In order to determine the direction of the force, you need to draw a picture. So whenever you are given a problem where you're trying to find the electric force between two charges, you need to use Coulombs Law and you need to draw a picture to get a complete understanding of what's going on. Your pictures are going to be really simple, right? If you have two positive charges, you know that they are going to repel and they're going to move away from each other. If you have two negative charges, these are also going to repel and move away from each other. And if you have a positive and a negative, you know these guys like each other, opposites attract. They are going to move toward one another. And that's basically the gist of what you guys are going to be doing in terms of drawings. It turns out we can have more than two charges. We can have 3, 4, 5, 10 charges involved. But we in this class are only going to be dealing with two charges at a time. So this is basically what your drawings are going to be looking like. So what the heck is that constant? Well, the constant is Coulomb's constant, and it is always 8.988 times 10 to the 9th. And it turns out because the unit of charge is a coulomb, in order to make all of the math work out with our units, the units for this constant are newtons times meters squared over coulombs squared. You guys might recognize that this is an inverse square law. We talked about that before we left for break when we talked about universal gravitation. So this is an inverse square law. As objects become farther apart, the force between them decreases with the square of the distance. So if we put them twice as far apart, the force decreases by a factor of 4, or 2 squared. If we put them 3 times as far away apart as they were in the beginning, the force will decrease by a factor of 9, or 3 squared. It turns out that the charges that are produced by rubbing things together, like a balloon on your hair, are typically around a microcoulomb. And remember, micro is times 10 to the minus 6. So if it's a dry winter day and you're in your stocking feet and you shuffle your feet around on the carpet, you are picking up electrons. And you will probably pick up about a microcoulomb worth of charge. And that is, in fact, enough to zap you when you go to touch the metal doorknob. It turns out a lightning bolt has a charge of around 10 coulombs. That's a lot. That's over 1,000,000 times more than the charge you will pick up by shuffling your feet around on the carpet or rubbing a balloon on your hair. So let's use Coulomb's law in a problem so you get an idea of how to use it. The problem is, determine the electrical force of attraction between two balloons with separate charges of positive 3.5 times 10 to the minus 8 coulombs and negative 2.9 times 10 to the minus 8 coulombs when separated a distance of 0.65 meters. The first thing that I want to do is draw a picture. What is going on here? So we have two charges, we have two balloons. So this is my balloon and here's another balloon. That is a weird looking balloon, but go with me. So this one has a charge of positive 3.5 times 10 to the minus 8. So this is overall positive. And this is a charge of negative 2.9 times 10 to the minus 8. So this is negative. So looking at this picture, we have a positive and a negative. Opposites, they are going to attract. So this is what will happen with these balloons. They will come together. Now that we know that, we can use Coulombs Law to try and figure out how much force will pull them together. We know, looking back at this slide, or looking up at the front wall above the whiteboard, that Coulombs Law is F equals K Q1 Q2 over R squared. We are trying to find the electrical force, determine electrical force. So we have nothing we can plug in for F. K is an easy one. K is always the same number. It is always 8.988 times 10 to the 9th. So we can go ahead and plug that one in right away. 8.988 times 10 to the 9th. K is done. Now what about our charges? Well, the first charge we have is 3.5 times 10 to the minus 8. So that goes in for Q1. 3.5 times 10 to the minus 8. And because we already drew our picture, and we already know that these are going to attract to one another, when I go ahead and do the math, I am going to ignore the charges in front of, or the signs in front of the charges. At this point, it does not matter if we put in a positive or a negative with these charges. All this is going to tell us is how big the force is. We already know the direction. So the other charge then, ignoring the sign, is 2.9 times 10 to the minus 8. And that is all divided by the square of the distance. These two balloons are 0.65 meters apart. And I need to make sure that I square that. And it's really important that you square just the distance and not the entire thing. So you can't do charge 1 times charge 2 divided by 6.5 and then square it. That doesn't work. That is not mathematically sound. So now it's a calculator problem. And this might be a big problem for some of you guys. Remember, parentheses, parentheses, parentheses. So when you plug this into your calculator, add as many parentheses as humanly possible. You have to keep track of them, but the more parentheses you add, the better it will be in the end. The other trick is, instead of writing 8.988 times 10 caret 9 every time, just write 8.988 E 9. And remember, the E comes from second, comma. Press the second button on your calculator and then the comma. That will help you a lot. So the way to go about this is to first multiply these two numbers together and then divide them by 0.65 squared and then multiply by K. So do the charges, divide by the square of the distance, times the constant. And when you do this out in your calculator, you should get this number for F. 2.16 times 10 to the minus 5. And this is a force. It's electrical force, which you haven't dealt with before, but it's still a force, so the units are newtons. If you put this whole thing into your calculator and you do not get this answer, you need to go back and check your parentheses, check your order of operations, make sure you squared the proper number, and check and see if you did this trick. So that's how you use Coulombs Law. You are going to apply it to your homework question, which you'll turn in the next time you come in for class. So the question says, imagine that after running the Van de Graaff generator for 5 minutes, it builds up 1 millicoulomb of negative charge. If I bring a balloon with a charge of positive 3 times 10 to the minus 12 coulombs to 0.5 meters away, what is the electric force acting on the balloon? And is this force attractive or repulsive? So remember, draw a picture, use Coulombs Law, make sure that you're putting everything into your calculator correctly, and you should be good to go.